Hi, everybody. Thank you for tuning in. Today, we're going to be talking to Becky, who is a mechanical engineer, and you may know her because she comes to our libraries very often with her therapy dogs, Chewy and Finnegan, but she's also got a really awesome job, and she's going to tell us all about it today. So take it away, Becky.
All right. So I am a mechanical engineer by education, and I am a car crash test engineer by trade. And one of the first things that I want to do is take you guys on a virtual tour of our crash test facility so that you can get an idea of the kinds of things that I and our team of folks do. And then we can chat a little bit more and have some question and answers where we talk about how I got here and all the things I do every day in my job. So here we go.
Hi, I'm Becky Miller, one of the senior research engineers here located at the VRC. Welcome to the Insurance Institute for Highway Safety's Vehicle Research Center. We're located in Ruckersville, Virginia, in the foothills of the Blue Ridge Mountains. This is the location where we conduct all of our car crash testing. We begin our behind-the-scenes tour in our vehicle display hall, sometimes nicknamed the Hall of Fame, Hall of Shame, because we highlight the best and worst of each of our crash tests. This provides us with an opportunity to share with you a history of all of the crash tests that we've conducted and their effect on reducing losses on U.S. roadways. All of our high-speed tests are rated on 4 different ratings: good, acceptable, marginal, and poor. The rating comes from 3 different things: vehicle structure, performance of restraints and kinematics, and measures from the dummy injury sensors. We are now outside of our dummy calibration lab, more formally known as anthropomorphic testing devices. The dummy is our main test tool for analyzing crash test data. Dummies come in all shapes and sizes. We have about a fleet of 20 dummies in frontal, side, and rear impact crashes. Dummies come in different sizes, all the way from a 6-month-old, 3-year-old, 6-year-old, 10-year-old, small female, mid-sized male, and large male dummies. This allows us to measure and understand different injury risks for different sized people. Our frontal crash dummies have sensors that are directed more towards the front. Our side crash dummies have sensors and abilities that help us understand side crashes. And the same thing for rear impact. So they're all very specialized. There's not just one crash test dummy. What you have next to me is our SID2S dummy. This is our standard side impact dummy. We've been using her since 2003 in our side impact crash. That's right, her. She's a 5th percentile female, about 5 foot tall and about 100 pounds. And she reflects the most vulnerable population that we noticed inside crashes. So she will be located in the front and rear seats of today's test that you'll observe. I'm often asked, how much does a dummy cost? It's pretty crazy. Dummies can range anywhere from $150,000 to $1 million. And it depends on the complexity of the dummy and the amount of sensors inside. Some dummies are even wireless. Dummies can have anywhere between 40 to 150 different sensors that measure things like accelerations, rotations, forces, displacements, and other things. So now I think we need to go and talk about the crash test process. The time it takes to crash a vehicle from the time it arrives to prep, to crashing, to being done with it is about a week. And the first destination that this car will come is to our photo studio. Our photo studio has soft diffuse light overhead, a cyc wall, and a turntable that allows us to adjust the vehicle to different angles. Our team of professional photographers take these photographs that are used for our websites, promotional materials, and research purposes. We can capture the same angle on every vehicle for a vehicle class. We can also capture those angles pre and post crash, so engineers can compare that data. So after they're done with their beauty shots, the vehicle moves to the vehicle prep area. Once the vehicle leaves the photo studio, it heads to our vehicle prep area. Our vehicle prep area consists of about a dozen technical staff that help support the prep and testing of the vehicle. The next step in the process is vehicle measurements. We use a measuring tool like this that's computerized to help us identify parts of the vehicle and locate them in 3D space, both pre and post crash. A tool like this is accurate to the micron. Once measurements are taken, it then heads over to one of the bays behind me. In this area, we install our own test equipment, and we install things like stickers and other components that help us for the crash test process. All of our test equipment in the rear of the vehicle are made by our electronics lab. So we control things like the vehicle system, cameras, lights, and brakes. We also install a different kind of fluid in place of gasoline that's not nearly as flammable, but helps us understand if there were to be a fuel leak. It's colored purple, which is different from any of the other fluids in the car. So if we do see a leak, it's easily identifiable and we can see the risk. Once everything is checked off of our list for vehicle prep, the vehicle can then head to the crash hall. We're now heading down to the runway to check out the moving deformable barrier before the crash. Each runway is 600 feet long with a temperature and humidity controlled shed at the end. So let's go. At the end of the runway is our temperature and humidity controlled shed. For today's side impact test, we have our moving deformable barrier back here in the shed. It's a generic cart that we can use to crash into every one of our side impact tests and creates the same kind of impact. So this barrier will be coming down the runway at 60 kilometers per hour and striking the side perpendicularly of the test vehicle today. In just a few minutes, the crash test team will be coming by to do their final checks on this, ensuring that cameras, braking systems, and the vehicle itself is ready to roll. Let's head down the runway into the crash hall. So we're heading back into the crash hall for the final pre-checks before we begin the test. You can see the team behind me is checking off the final list items, including making sure that the dummies are fully positioned, final measurements are taken, dummies' heads have been painted, so we have that kind of paint evidence. They'll also be checking other aspects of the vehicle, and when everything is signed off, they'll be ready to roll. So let's head up to the gantry and make sure that we are ready and in position for the final checklist. We're here in the gantry in the crash hall. We're waiting for the final countdown. In the meantime, I'm going to give you a few quick crash facts about our crash hall. We have 3 runways in our crash hall. We're able to run parallel crashes of 2 full-size pickups into each other at 50 miles an hour from these 2 runways. We also have a 3rd runway in which we can run a T-bone style crash up to 30 miles an hour. For single vehicle crashes, we actually have to pull a barrier in the middle of the crash hall. That barrier is made of concrete and weighs 320,000 pounds. Our crash hall also has soft diffuse lighting system. This is to prevent shadows. 750,000 watts of light are given in 3 phases through these light boxes. Lighting is very important when we have high-speed video footage. Our cameras are able to capture a frame every 2 milliseconds during the crash. This data is very important to us because it helps engineers understand the kinds of injuries and risks that are happening. It's amazing what you can see happening in 2 milliseconds or 4 milliseconds during the actual crash. A crash itself only lasts about 100 milliseconds, which is in the blink of an eye. The crash machine operates off of hydraulic power. It takes about 4 minutes to charge the system to be able to run the test. The vehicle will be coming from behind us at 60 kilometers per hour. That's about 37 miles an hour. And it will hit perpendicularly with the test vehicle that we have today. So let's step back and watch the crash.
Charging is complete. The test will commence in 4 seconds. 3, 2, 1. The vehicle is underway.
The crash test team is checking out the scenario right now. They're doing some initial measurements and observations and securing the facility so that we can then go down on the crash hall and take a closer look at the vehicle. One of the most common questions I get is, how did the vehicle do? How did it perform? What rating would it get? Let's go back to the 3 different principles that we have for rating vehicles. Vehicle structure. When we look at this vehicle, it still has a relatively well-maintained safety cage. So structure was pretty well maintained. We won't know the exact numbers until this afternoon when we take the vehicle back into the photo studio and do detailed measurements of both the vehicle with the doors on and vehicles with the doors off to get those exact numbers. We also will be looking at the restraints and kinematics. So the airbags did deploy, and we don't see any evidence that the dummies were able to get out from underneath those airbags, but we'll look at the high-speed video footage to ensure that the airbags came out in time to protect both the front and rear dummy passengers' heads. The third thing is to look at the dummy injury measures from the sensors. The dummies are able to download their data almost immediately after the crash, so within 5 to 10 minutes of a crash, we can get an idea of the injury risks that the dummies are indicating. For this test, we did see a slightly elevated chest and a slightly elevated pelvis for these dummies. While overall we can't tell you what this rating would be, we can give you an idea that this vehicle did a pretty good job of protecting the occupants in this crash. You'll have to wait and find out our final ratings on our website when they're released. From here, where does the vehicle go? The vehicle is going to go back to the photo studio where we take more detailed measurements and a tear down of the vehicle to take pictures and measurements of each step of the way. This is used for engineering analysis as well as for our final ratings. In a typical crash test, by the end of the day, we have all of the components necessary to create a draft rating for the manufacturer. So they walk away from our building at the end of the day with an idea of how their vehicle will rate in this new test. This brings us to the end of our behind-the-scenes tour at the Insurance Institute for Highway Safety's Vehicle Research Center crash test. I hope that you had a good time, and I hope you learned a lot, and please come back again in the future. Thank you.
All right.
That was awesome.
So
I
it's a lot
guess-
of fun stuff and a whole team of people. Like we said, about a little over a dozen people make this happen. It's a big team effort.
That's really cool. So I guess that pretty much answers the question of what do you do? 100%.
Well, my role, so this is all the fun part,
Mhm.
and it's only like 10% of all the work that we do.
Okay.
So there's a lot of research to figure out what kind of crash tests are important that will help reduce the number of people dying on US roadways. So a lot of that is number crunching. We're looking at data from government statistics and actual crash reconstructions. So kind of like CSI work, where we're looking at like the evidence from an actual crash that happened, that some investigator put all this evidence together, and we're looking at medical records and all of the details and trying to figure out, okay, all of these crashes could be avoided or reduced if we had this new test that improved these parts of the car. So then we do research to figure out what kind of test we would want to create. And this is the culmination of it. This is the new test mode that we've come up with. And it can take 3 to 5 years to develop a new test.
Oh,
So it's a
wow.
long process.
Yeah. So you mentioned something about crunching numbers. So I'm guessing that means So anytime I hear something like that, I'm thinking math. Do you have to be mathematically minded or have strong math skills to be in your field, or is it?
You have to be able to do math, but you don't
Okay.
have to love it. That's, I think, a misconception that I think a lot of people have about engineering in general
Right.
is that, you have to be able to do it. But
Mm-hmm.
actually, once you get out of school, the amount of math that I do is typically related to Excel sheets. I'm
Sure.
I'm, adding, subtracting, multiplying columns, just volume of data, but it's not super hard, crazy formulas with all those Greek letters.
Sure.
And so I want to kind of debunk that myth that you have to be some math genius in order to be an engineer. It's just not
Right.
true.
Mm-hmm.
There's a lot of applications of math,
Sure.
and that's more like the physics and the the building things and the breaking things kind of side of it that you have to
Mhm.
be passionate about for at least mechanical engineering.
Right. Okay. So that kind of goes into the my question about your educational background. So what did you study? What are your degrees in, or do you, and is everybody generally there are some professions where people will have many different degrees and they're doing similar or the same job. So what is the typical, what is yours, and is it a kind of uniform across the map?
So I have a bachelor's and a master's degree in mechanical engineering. We also have people that are in transportation engineering, civil engineering, electrical engineering, and I have other colleagues in a different department who are a lot of behavioral science type folks. So, public health and psychology and human behaviors and statistics. And those people look at the problem from the other side of understanding there's always a driver, at least
Hmm.
right now in cars, and what role do they play, and what can we do to fix issues related to the person driving the car. So
Right.
it's a pretty diverse group of engineers and scientists that all come from different perspectives. And that's what's
Okay.
really cool about this team environment, too, is that maybe you're seeing things through your engineering vision, but your coworker may see things through the behavioral science, vision of theirs. And that makes a better assessment and could create a better test.
Right. Okay. So it really takes like a team of a lot with a lot of different perspectives. So it's not just like this uniform kind of um, thing, which I guess makes a lot of sense because when you're doing something as crucial as crash testing, you want to have every angle covered. I feel like you don't want to have any corner unturned, so to speak.
Yep.
So did you, before you got into your current job, did you ever have to do internships, or did you have any sort of like vocational stuff that you had to do beforehand?
I did. Mechanical engineering is a really broad field. And
Okay.
that's one of those fields that, you take a lot of different classes and you're kind of wondering what part of this do I really like?
Hmm.
And so I did internships in various areas to try to figure out, okay, what aspect of mechanical engineering do I really enjoy? Do I like working with gears and mechanical components? Do I like working with thermodynamics and fluids and refrigerants and basically like HVAC systems? Do I like the manufacturing side of things? Am I more interested in the biomedical side of things as well? And so there's a lot of overlap between mechanical and biomedical. Um, so those are all different options. And I was able to do some different internships, including an internship at General Motors
Oh, wow.
where I got my foot in the door of automotive safety. And I really got to learn. I got to see my first crash tests. I got to learn the process of how to build, a car and create all these airbags and seat belts and everything that protect people in crashes. And it really solidified for me that I wanted to work in that like more like medical crossover area
Okay.
rather than the mechanical steel and aluminum and rubber kind of
Right.
aspect. So
Right.
yeah,
That's awesome.
internships are a great opportunity, and Another thing I really recommend for people is to get experience at a small company and a big company
Mm-hmm.
because there are pluses and minuses of both.
Mm-hmm.
And some people thrive in a big company and some people thrive in a small company. And you've got to test it out first to figure out where you think you best fit.
Sure.
It's like with colleges. There's tiny colleges, there's mid-sized ones and huge ones.
Mm-hmm.
And you might get along in all, but you might have one that really just suits you.
Right. Yeah, exactly. That's a really good point. So was it always your plan to go into this, to go into the engineering? I mean, the engineering field is massive. So was this always your plan? Did you have something else in mind, or did something come up in your life that made you go, oh, this is where I want to be. This is what I want to do. Like, how does this, I don't imagine people grow up thinking about crashing cars.
Most people don't. I did. And so I had an experience when I was 10 years old. We were sitting at home. I really liked cars at the time.
Okay,
Kind of an odd thing, but I did.
sure, why not?
It's so cool. I think they're cool. So I was at home with my parents and we were watching the evening news. And at that point, I had always said that I wanted to be a doctor. Like I was going to like save people's lives. And um, I saw the very first car crash tests from the Insurance Institute for Highway Safety on TV,
Mm-hmm.
and it clicked for me. It was like I can work with cars
Mm-hmm.
and I can work in a situation where I can save people's lives.
Yeah,
And actually, I can save people's lives without ever having to meet them.
right.
You know, I can do something that influences just people all over the country.
Mm-hmm.
And I thought that was the coolest thing. So I worked towards goals that could get me closer to that. And
Right.
so it was, find out what kinds of classes I would need to take in high school to then
Mm-hmm.
get to the college that I wanted to get to the degree that I thought that people were using to become a car crash test engineer,
Mm-hmm.
and then in college joining clubs and organizations that again got me closer to having experience but also having connections with
Mm-hmm.
people. I got my internship at General Motors because I had met someone through a hybrid vehicle team, someone who worked at GM and was hiring interns. And so a lot of it seems like it's just luck and things
Mm-hmm.
fall in your lap, but it's a plan. You've got
Sure.
to have a plan.
Mm-hmm. Oh yeah, absolutely. So I think it's really cool though that you like this was what you wanted to do as a child, and that's what you're doing. Like I think that it's very like there are some people who wake up and go yes, or figure out what they want to do very early, and then there are people like me who just kind of like bop along and then figure out hey. So the fact that you identified it right away and then it worked is really, it's pretty extraordinary to me at least.
Well,
Um,
and not knowing is fine too.
yeah.
I mentor people that say, they're disappointed to hear that I knew what I wanted to do and I just went ahead with it as if that
Hmm.
sounds easy. But also it's not easy when you don't know.
No.
And it takes a lot of thinking about what you like and dislike about jobs and
Sure.
sometimes moving around. And I think
Hmm.
that can also have a lot of really great stories and really great
Right.
experiences that you carry from one thing to another.
Sure. And even having like even like identifying what you want to do, like that's the only the beginning. Like you still have to, as you mentioned, have a plan. Like, okay, here's this thing that I like doing, but how am I going to get there? What can I do to
Exactly.
get there? So there's really not, it doesn't necessarily make it easier if you like, well, if you know what you want to do, like that's one advantage, but like you still have to figure out how you're going to do it. Is it feasible? Is it realistic? So, um, but I still like, I think that's super awesome though, that you were able to identify very early that that's what you wanted to do. And then you did it. I feel like a lot of people like don't get to have those types of stories. So that's pretty awesome to me. So what's a day, what if like, do you have a typical day if there is one?
I have two types of typical days.
Okay.
Either they're days when I'm analyzing data and I'm sitting at my computer, typically alone. It's not a teamwork thing at that point. I'm looking at stuff.
Mm-hmm.
Um, or writing up summaries. So we do a lot of writing and a
Mm-hmm.
lot of PowerPoints and communications in different ways that aren't necessarily what engineers think they're going to do. But when you do some really interesting science, you have to be able to communicate with people. You have to be able to communicate the value of the thing that you just discovered or the
Mm-hmm.
thing you just made, and you have to communicate it to audiences who aren't all like you.
Sure.
You need to be
Exactly.
able to tell your Uncle John, here's what I did, or
Mm-hmm.
tell the investors
Right.
about why they should invest in your product and those kinds of things. So I do spend a lot of time doing those kinds of communication exercises.
Mm-hmm.
When I'm doing testing, I'm in the lab, I'm with a team of people, and we're all kind of bringing our part to the table. So
Mm-hmm.
that's almost like a stark contrast, the opposite,
Mm-hmm.
where you're working with a lot of people, you're bouncing ideas back and forth, and you're having to think on your feet. And
Mm-hmm.
that's more of the exhilarating, exciting part of it. But
Right.
there's a lot of responsibility that goes with it. If
Mm-hmm.
you pick a test, you're trying something out and then it fails. First of all, you got to explain why the results didn't turn out as you hoped, and the
Mm-hmm.
money that was just put towards this failed experiment.
Right.
And then you have to be able to come up with, here's our next step.
Mm-hmm.
And sometimes on the fly, like I may have a test on Tuesday that goes not as we hoped. And then Thursday, we already have to have a new plan for that test. So
Right.
I've got a day and a half to say, okay, we need to change up this, add that, remove that. Can we get this done on time? Or do we need to delay things?
Mm-hmm.
And work with people in that aspect, and work with people's strengths, learn what people's strengths are, and use it to the advantage of the whole team.
Awesome. Yeah. And I like that that you put some emphasis
So
on.
it's two very different things. Exciting. Yeah.
Yeah. Oh, sorry. I think we had like slowed in a second. I thought you were done. That's okay. We can edit this out later. It'll be all right. Um, but I do like that you mentioned the importance of clear communication and be in writing. Like one thing that I know I have experienced from doing various tutoring types of gigs is you get kids who say, I'm going to do this because I don't have to worry about my writing skills or communication skills. So it's like, no, but no, you do need to know how to effectively communicate with not only with your peers, but people who do not understand the vocabulary that comes with your career. So it,
Every business, every workplace has people that are not
sure.
technical experts, people that are not engineers that are part of your team in some capacity. So
Mhm,
we all have to get along and we all have to be able to communicate. Most often, the bosses of the world, the people that have the money and the power to do things, aren't as technically knowledgeable as you are. And
mhm,
so you have to be able to sell your idea, your project, the value of whatever you're doing with those people. But even just simple communication to be able to convey, okay, here's what Thursday's test needs to look like.
mhm.
And this person, call out a person and say, this is the task I need you to do. That's important communication.
Yes,
It
it is.
sounds simple, but it's important. And if you don't
Yes,
communicate it correctly, then the widget that you made isn't the right widget.
right.
So,
Mhm. And that also goes into like the importance of what your job is because you're doing these tests, and if the dialogue surrounding them is ineffective, you've completely, like you mentioned, you've potentially blown a test that was expensive and necessary. And so and then you just have an ineffective result, right?
Right.
So that's, I mean, that's a pretty that's a pretty big thing. And we've talked, I think we've talked, I think it's very clear, like in your mind, what is the most important part of your, would you say is the biggest important part of your job? Like I think it's obviously very clear to me that what you're doing is a very big deal because you're making sure that people are safe when they're driving, which is a huge, huge, huge endeavor. Um, so would you like what, um, so in your mind, is there, is, it's like, what is your big, like, what is it about your job that makes you like look forward to it or makes you feel fulfilled or
I think it
anything?
really is that human aspect.
Right.
And knowing that what we're doing is something that will have a positive impact on society.
Mm-hmm.
And we get messages every once in a while from people who actually send us photos and say, you know, I picked a safe car and I was in a crash and I walked away from
Mm-hmm.
this crash because of the work that you do, the things that you promote, you know, safer vehicles. And that's very heartwarming. I think
Mm-hmm.
at the end of the day, everyone in our field is someone who got into it because we care.
Sure.
And maybe we weren't meant to be a doctor. Like we all have that same kind of I want to save someone's life, but
Mm-hmm.
we realize that our talents are not to be a surgeon or not to be a doctor. But
Right.
this is how we can bring our talents to the table
Yeah.
of doing something positive for others.
Mm-hmm.
And so that's really the best part of all of this is to see that direct relationship between the work that we do and the people who have a positive outcome on their lives.
Mm-hmm. So what happens if a so I'm assuming if something, if a test, if a car fails a test, what do you have to, will it just be retested and redone until it passes, or how does that usually go?
So they would have to show us that they've made changes.
Okay.
And if they show us significant changes made to the vehicle, we would then agree to retest it and um, apply a new rating to the vehicles moving forward from that point. If there's
Okay.
some sort of defect and they fix it, then we could retroactively apply that rating to the vehicles that were fixed as well.
Okay.
But it's a very competitive market where
Mm-hmm.
every car brand wants to have all these awards. Safety's in the top 5 things that people
Mm-hmm.
look for when they're going to buy a car. And so if, you know, manufacturer A is getting a good rating, but manufacturer B got a poor rating in the same test, manufacturer B will want to quickly make the changes to get that same good rating to be able to
Mm-hmm.
be competitive.
Right. Right. Yeah. I mean, I know I picked my car because it had high safety scores and the review said it was boring. And I'm like, excellent. I want
That
safe and boring.
that
That
is actually that is what we recommend for teenagers. We have
is
also a list of recommended cars for teenage drivers, and they are cars that get all of our best, you know, safety ratings and are relatively low horsepower, kind
sure.
of big sluggish vehicles because
Right.
we don't want to tempt anybody to be wanting to drag race down the street in these
Sure.
vehicles.
And I would imagine also for teenagers, cars that are sturdy, you know, that are durable, that if they get a couple bumps, it's not going to completely wreck the vehicle. Um, I know you'll probably cringe at this. I drove for a very long time. I drove a PT Cruiser, and those things, I mean, it's like a negative score on frontal collisions. And I'll tell you, I learned this a two times from testing it myself, if you will. And so, you know, and but that's a really important thing that people think about. Like when, especially, I mean, it matters for an adult, but especially for a new driver, like you don't want something that is not going to keep you protected.
Exactly. And we have cars that we can recommend all the way down to the $5,000 and under category. So
Oh, that's excellent.
you don't have to buy like a brand new, you know, $50,000 Mercedes in order to keep your kids safe. Like this is the
Sure.
message that luckily, now that we've had all these tests for so long out there, there are used affordable vehicles that are safe and good for your family members who can't afford like I said, the brand new BMW. So
Sure. Yeah. I wouldn't even know what, gosh, I don't even know what to do. I wouldn't know what to do with a BMW.
it would be nice.
It'd be
So at
fancy.
the heart of it all, I just love being around cars.
Yeah.
And so it's thrilling to me to see all these new cars come in. It was especially fun when we had some of the sports cars that we were
Mhm.
testing. We had the Mustang and the Camaro, and that was cool. But it's just fun to see the new technology that's coming out and
Right.
new vehicles. So.
Is there like a type of a brand or a new car that's up and coming that you're really looking forward to getting to test, or is that like confidential information?
I don't know what we have up and coming. I know that there are more electric cars that are coming to the
Okay.
market,
Mm-hmm.
and so we'll be testing more of those in the future. Um, and I've heard a lot of cars coming in the next couple of years that are either hybrids or electric vehicles.
Mm-hmm.
There's a
That's
big
excellent.
push to reduce, improve fuel economy in that sense. So.
Oh, sure, definitely. So what would you say, what is your favorite part of your job? Like, what is I mean, apart from the fact that you get to help so many people, probably for like generations of people. Is there some part of like your day to day that you just get really excited to get to do?
The crash test, watching the crash test is still absolutely the best thing. There are people that have gotten jaded by it. I don't see how they could.
Right.
The people, I talk to people that have been in the industry for 20, 30 years. Oh, another crash test. I don't get it because everyone's fun.
Sure.
Every single test is fun and exciting, and you still don't know how it's going to turn out. You
Right.
think you know, you don't, and that's why we have to do it.
Mm-hmm.
Like from a money standpoint, if we already knew how it was going to turn out, we wouldn't do it at all.
Sure.
Why bother? And so there's still surprises to be had.
Oh
We had a
yeah.
very exciting test last year where we had a Jeep that actually it was a front test and it flipped over. And that was the first time we'd ever had a vehicle flip over in one of our
Whoa.
crash tests. So
Mm-hmm.
you just don't know.
Right. And you probably were not anticipating that the car would flip.
Not at all. Not at all.
Like you don't walk into it going, let's watch some cars flip today.
Unless you're running a rollover crash, but yes, unless that was your plan. But if it's not your plan, it could be surprising. So we've seen a lot of unique things over the years.
Mm-hmm. What would you say is like the biggest challenge? And I'm not saying necessarily like things that you dislike, but just like those aspects that you have to maybe push a little harder for or keep or that you have to work on your motivation a little bit more to keep going with.
I think it really is aspects of communication,
Right.
and everything comes back to communication. Um, we have a distance with the manufacturers. We don't work with them.
Right.
But it's also a negotiating game to be talking to them and conveying, here's why our test is important. And
Mm-hmm.
we recommend you redesign your vehicle to meet the standards of this test. But we have no power over them. We're not
Mm-hmm.
the government. We don't regulate. We can't say, make these changes or you can't sell your car or something
Okay.
like that. We're here to give information to people,
Mm-hmm.
and we think the information is valuable. We have to provide our arguments as
Mm-hmm.
to why we think our research is valid
Right.
and why we think this should be important to you too,
Mm-hmm.
kind of thing. That's a huge challenge depending on the personalities, depending on the culture of the company that you're talking to.
Mm-hmm.
You have to be able to adjust to it.
Mm-hmm.
And we talk to all the manufacturers. So one day we may be talking to folks that are from Korea, and the next
Mm-hmm.
day Japan, and the next day Germany, and the next day Sweden. And you have to account for people's cultures, the
Oh,
company
absolutely.
cultures, the language barriers that sometimes we have to overcome. There's just so many different aspects. They're challenges, but they're the kind of challenges that you want to step up to.
Right.
You know,
Okay.
you wanna
Yeah.
kind of, you don't say, "Oh, this is too hard," and wave my hands and I'll give up.
Hmm.
It's the reward is so great there that you but it is a challenge,
Right.
you know?
Yeah.
It's like
But you,
no 2 days
yeah,
are the same in that sense.
sure, sure. Like you, it's not something that that it makes you want to like, that deters you from the career. It's just that
Right.
little thing that you've got to put a little bit more into, perhaps. So that's fair. Um, so what suggestions would you offer to people that might be interested in this career, whether they are, I don't know, like maybe they're a high schooler who was getting ready to go to college, or maybe there's somebody who's in it or about to get out of college. Um, what type of input would you offer to those people?
Well, I think the for people who don't know what they wanna do or don't know where they wanna work, do some research and figure out, first of all, what do you like? And then look up what kind of careers people have that do the thing that you like. And then reach out to some of those people. We live in an age where people are accessible. Like when I was doing this, I was just kind of stabbing in the dark trying to figure out what kind of careers and what kind of degrees and stuff these people on TV had. They didn't
Mm-hmm.
have web profiles or anything. So reach out to some of these people and say, "Hey, I'm a high school student. I'm interested in pursuing this career path. How did you get here? What degree do you have? What education? What skill set do you have?" G- Build ideas, build a roadmap from learning from others who have already been there.
Mm-hmm.
And then take that information to try to start on your roadmap, start on
Right.
your path. And whether it be applying to college or applying to a degree field in your college, or getting the first job at a certain company that you know will then result in being able to go to other companies. But you need to get like a plan. And
Sure.
and I've said it earlier too, but
Mm-hmm.
you really do need to start figuring out a plan and plan for road bumps.
Oh, sure.
Like, plan for not everything it's not gonna be a plan that goes in a straight line to your
Right.
destination.
Mm-hmm.
It's gonna be things that are detours, sometimes detours that even look like you're going right back to where you started,
Right.
but you have to figure out how to navigate all of these things to get to the end.
Mm-hmm.
And I have and all the people that I have reached out to in different capacities, no one's ever said no.
Right.
People love to share their experience with someone
Mm-hmm.
who's coming up the ranks, some coming up the line. So, you know, do some research. You have all these resources at your disposal that we didn't have 10, 15, 20 years ago,
Mm-hmm.
and start pursuing something. And if it really isn't the thing for you, then go back to the drawing board, reevaluate what's the new thing that another thing you like to do, and how
Sure.
could that be something that could be a career path.
Hmm. Yeah, definitely. And if at least from my experience, most like people who were really happy in their jobs, well, even people who are not very happy, frankly, are very interested and they are very willing to share their experience. Like they like to talk about it. Um, and I know, like I always tell people who, like, if you encounter somebody who's negative, find another person to talk to, because if that's something, because there's probably a reason why they, like maybe it didn't go how they wanted it to. Um, but for me, and at least in my experience, like you can kind of tell, like when you speak to somebody who really who's passionate and who cares about what they're doing, they love to tell you about it. And they're enthusiastic about it, and they're excited about the fact that you want to come into their field. Um, would you say your field is a competitive one, or is it kind of like a middle of the road, or just depend?
It's kind of your middle of the road
Yeah,
normal.
that makes sense.
And it's a very tight knit community. So even
Mm-hmm.
if they do move, they tend to move within the community. So
Right.
Someone working for manufacturer A might now be working for manufacturer B, and that kind of thing.
Right.
Or even within a company, there's the bigger companies have more opportunity to advance and be
Sure.
managers and learn different aspects of things if that's something
Hmm.
people like.
Awesome. Okay. Well, are there any closing remarks, that anything that we didn't get into that you would like to share really quick, or because this was awesome.
All I'll say is never give up. When it looks hard, when it looks like maybe this isn't for me, try to again figure out a way around the roadblock and keep moving towards your goal,
Hmm.
because you don't have to be perfect. Perfect is actually not a good thing for science and engineering. You can't handle when that experiment fails if
Hmm.
you're so obsessed with being perfect. But yeah, just never give up. Just always recoup, figure out how you can pick yourself back up and keep moving forward.
Excellent. Awesome. Well, thank you so much, Becky,
Yeah.
for talking with us. I'm really excited to share this video with everybody. I think it's going to have a lot of traction. I really do.
Awesome. Thank you so much for this opportunity.
Yeah, that was great. This was so great.